Welcome back to video 6 on vectors in 2 dimensions. We're now going to look at unit vectors and scaling with the vector I and the vector j. A vector of length 1 is called a unit vector. Let's see if we can take the vector v with components 3/5 and 4/5 and check to see if it's a unit vector. We can do this by using the magnitude formula to see if we'll come out with a length of 1. Checking for the magnitude of v, we'll get the square root of 3/5 squared plus 4/5 squared. Simplifying this, I'll get 9/25 plus 16/25, which is equal to the square root of 25/25, which is equal to the square root of 1, which equals 1. So the magnitude of the vector v is 1. Now let's check the u vector with components 0, 1. This one's easy because if we look at the components, there's 0 direction for x, it's all vertical direction for v. If we call a vector with unit length a unit vector, this vector is exactly 1 unit long. We could also show this by using the formula we just used for the other vector. The magnitude of u is equal to the square root of 0 squared plus 1 squared. This will give me the square root of 1, which is equal to 1. But now let's use this information a little bit more carefully. This is a unit vector, this vector u, but there's a special name for these vectors when they're 0 in one direction and 1 unit in the other. We call these vectors the I vector and j vector, and they're used so much in physics. You can't get away without knowing them in physics, actually. And they will come up again in calculus a lot. So basically, you use these vectors, I and j, to build another vector, and you use these as components. So it's kind of cool. Given what we know about component vectors, let's draw these two vectors out. We'll call the I vector the blue vector in my case, and I is all along the horizontal axis. If we say that this end point along the x-axis is 1, this is a vector with no rise, it's all run, and it's 1 unit long. In the horizontal direction. Now we're going to take j. This has 0 change in the x direction and a whole unit of rise in the y direction. It's also 1 unit long. So we will use these two vectors, the I and the j vector, to describe how a vector is composed. So we'll still use this idea of components, but now we're going to add these tiny little unit vectors together to describe a bigger vector. So if we wanted to take these vectors in terms of I and j, we would add multiples of I and multiples of j to describe a vector that is not units long, it's some other length. So if a vector u has components a, b, where the x and y directions are listed respectively as a and b, it can be expressed in terms of the unit vectors I and j by writing it as u is equal to ab, but is also equal to a times the vector I plus b times the vector j. Now you have to keep in mind that I and j are unit vectors, so they're only 1 unit long, which means when you scale them by an a or a b, it's going to scale them horizontally and vertically, respectively. So let's write the vector v with components -4, 7 with the terms of I and j. This is the -4 is my a value. We could also say the horizontal movement or horizontal change. And the 7 is like my vertical change. So if I want to describe this with respect to unit vectors, I will say -4 times the I vector plus 7 times the j vector. And this is the standard basis form. Now let's look at example 10. If u is equal to 2j and the vector v is equal to 3i plus 4j, write 2v minus 3u, so the 2 times the v vector minus 3 times the u vector in terms of I and j. So first let's combine the v and the u vectors and their scalars. We want 2v, so I'm going to replace the v with 3i plus 4j, and then I'm going to subtract 3 times the u vector, and the u vector is just 2j. Now let's just take this information and distribute the 2 through and the -3 through. That will give me a 6i plus 8j minus 6j, and that combines to give me 6i plus 2j. And you can go through and put little vectors on top of all your i's and j's. And that pretty much is all there is to it. You just have to keep track that when you're talking about i's and j's, it's like saying 6 times the little vector 1, 0 as a component vector plus 2 times 0, 1 as a component vector. Because we're scaling how far we're going in the x direction, and we're scaling how far we're going in the y direction. And so the final vector represented is a sum of both of those directions. So you can't get this confused with component form because it's a different way of writing the little components as unit components scaled and then added together. So it'll take some keeping track, but once you can keep track of them, it's not that bad.